Okay, today we're going to talk about standard form of quadratic function. Actually, we're also going to talk about vertex form. We're going to kind of compare the two. So vertex form, you can see here, is one we've used more of. We haven't used standard form very much of, but that's actually, you'll see that quite often. So I have two functions here. So they're both quadratic. And we're going to show you kind of what the benefits of each one are, what are kind of nice. So one thing that's nice in standard form is if you plug in 0 for x, very quickly you see that this value is always the going to be, oops, there we go. That's always going to be the y-intercept. So the c value is your y-intercept. So in this case, plus 3. If you plug in 0 for x, substitute in 0 for x, you get y equals 3. So y equals 3. This is your y-intercept. It's the one really nice thing about standard form. You can find that y-intercept really quickly. There's some other things we can find from that. We'll get to that in a minute. But also we're going to look at this one and find this one. What stands out in this is the h and k. H and k is the vertex of the parabola. So right away you can see the h is positive 1 and k is positive 4. So 1 comma 4. So 1, 4 is the vertex of this parabola. That's the vertex at 1 comma 4. So by the way, parabolas are super, they always are symmetrical. So I'm going to draw a line through this vertex. It's a dotted line where x equals 1. By the way, the formula for that, if you're in terms of x and h, is the axis of symmetry is the name for what I just drew. Axis of symmetry. The formula in terms of h is x equals h. Basically, the x value of this vertex is always going to go through the vertex, and it always cuts the parabola exactly in half. And so that's the formula of your basic parabola in vertex form. So it's symmetrical. And what that means is here, if we know the vertex is at 1, 4, and that point there is there, we know there must be another point on this side that is completely symmetrical from that point. In fact, at this point, you could almost sketch a really rough drawing of the parabola. If you knew at least 3 points, you kind of know it has that kind of a look to it. Something like that would be an okay graph of that. I might like to get a few extra points. So some other things I'd like to do, if you know, finding things, is I might, like I found the y-intercept, but I haven't found the x-intercept. So there's a couple different ways to find the x-intercepts. One way is just to plug in, like y is 0 in this case. So 0 equals negative x squared plus 2x plus 3. Not sure if this can be factored or not. That negatives in front is messing me up, so I want to, always that leading coefficient should be positive. So to divide each term by negative 1. And you get 0 equals x squared, positive, minus 2x minus 3. Now I'm going to try to factor that, because I have a feeling it might be factorable. So we have 3 and 1, in this case minus 3 plus 1. So the solutions are at x equals 3 and x equals negative 1. So I'm actually doing a little bit of factoring work here. X equals 3, x equals negative 1. This is certainly enough points to draw a really nice parabola at this point. And draw your arrows, and you've got it. So we could find the x-intercepts just by setting the y value equals 0 and solving. So those are how you can get some critical points on this graph. Let's look at this one here, and we're going to learn how to, I think the first part of this lesson is, it's just standard form of quadratic. So we're going to learn how to use the standard form of a quadratic to solve it. And then we're going to find the vertex, the axis of symmetry, some things I haven't talked about, the max or min value, and the range. Again, the very first thing you might find is right away you see that the y-intercept is 3 for this one. If you plugged in x is 0, you can see that the y-intercept is 3. Now, I prefer you to think about this as part of the quadratic formula. If you remember the quadratic formula, it's x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So the key thing I want you to see there is this is the center of the parabola plus or minus this amount. Let's look back at this one and let me show you what I'm talking about. So on this one, let's erase this. Let's start the quadratic formula and see what it looks like. So this would be x equals the opposite of b would be opposite of 2 over 2 times negative 1, which is negative 2, plus or minus square root of b squared, which is 4, minus 4 times negative 1 times 3, which is 4 times negative 3, all over negative 2. So this is positive 1, because negative divided by negative is positive, plus or minus. Let's see, 4 plus 12 is 16. Square root of 16 is 4. 4 over negative 2 is, so we have 1 plus or minus negative 2. So 1 plus 2, or 1 plus negative 2, 1 minus negative 2. I'm adding 2 and subtracting 2. So look at the axis of symmetry. It's x equals 1, right? This part of the quadratic formula is always the center of the graph. It goes right here along this axis of symmetry. And I'm adding and subtracting 2. On the x-axis, you see if I add 2 units here, I get to that solution. If I go 2 units to the left, I get to that solution. I'm adding, subtracting, in this case, negative 2 or 2 units there in each direction. So it's a different way of thinking about it, but you certainly could think about it that way. And so the key thing I want you to see here is that this is the formula for the axis of symmetry. So we don't have to solve this and put it in another form in order to find out where the axis of symmetry is. So as long as we apply this formula, x equals, the opposite of b would be opposite of 2 over 2 times 1, which is negative 1. So x equals negative 1 is the axis of symmetry. So I'm going to draw an axis of symmetry right there. It's a dotted vertical line at x equals negative 1. That's your axis of symmetry. I want to make sure I answer all the questions. So I have the vertex. Oh, we don't have the vertex, right? So there's another step to find the axis of symmetry. So I know, like, this is equal to h, right? That's the h value of my vertex. I need to find k. So to find k, the step you do is plug in h to find k. To find k. So in this case, you're going to have, I'm going to plug into the function here. So it's going to be y equals, instead of x squared plus 2 times x plus 3, we're substituting in there a value of h is negative 1. So I'm plugging in negative 1 in there, plugging in negative 1 in there. And so this will simplify to y equals 1 minus 2 plus 3. 4 minus 2 is 2. So my y value of that vertex is 2. So that's my k value in this case. And if you know that point, you certainly know this other point over here. And you could, at this point, if you needed to, almost sketch out the parabola. If you have at least 3 points, you could sketch out the parabola. Learning or applying kind of what we learned the other day, you could actually go over 2, up 1, 2, 3, 4, and make a point, over 2, up 1, 2, 3, 4, and make a point, and plot a beautiful parabola right there with 5 nice points. So this one, again, we're just going to apply the, we didn't quite finish answering the question. I want to make sure I answer that. So the max and min and the value of the range. So what's interesting here, the max or min value. So it's now talking about the ordered pair. I know the ordered pair there is -1, 2 is my h and k. The value is how low or high where's the maximum? That's how high it goes. Where's the minimum? That's how low it goes. This doesn't really have a maximum. It goes up forever here. But it does have a minimum value. So what you're really looking for the minimum in this case, the minimum value, this is a numeric value, is equal to 2. It's just a value of k. So the minimum is 2. And the range is how low and how high together. So the range in this case would be from 2 to infinity. So the range are all the possible y values. It goes from a low of 2, that's the minimum value, to a high of infinity there. So lower bound, upper bound. Okay, so let's try this one more time, make sure we're getting it. So the first step is to apply our formula. So h equals the opposite of b over 2a. It's actually just a formula we're going to use. So the opposite of b would be +3 over 2 times -1. So this would be, what, -3/2? That's your h. To find k, what do? We plug in h, right? So did I say h last time? Yeah, we plug in h to find k. Good. So into the function, everywhere there's an x, I'm going to plug in -3/2 and see what happens. So y equals, this will be negative something squared minus 3 times something plus 6. So in that something is going to be this -3/2. -3/2 here. So let's do order of operations to make sure we simplify this correctly. This is going to be negative. When you square -3/2, negative times negative is positive, so it becomes 9/4. Minus a negative, so this is like plus a positive there. 3 times 3 is 9, so 9/2 plus 6. So now I just need to add these terms together. Right now they don't have the same denominator. I can multiply this by 2/2. I can multiply this one by, what would that be, 4/4. And if I do that, I get -9/4 plus 18/4, which is positive 9/4, plus 24/4, 9/4 and 24/4, 9 plus 24 is 33. So that'd be 33/4 would be the value of k, right? So you're now going to go over to the graph and let's plot that point. -3/2 is -1.5 and 33/4 is, let's see, 8 times 4 is 32, so 8 1/4. So -1.5 for the x value, and the k value there is 8.25. So 8.25, somewhere right in this area would be my vertex. And what's nice about this one is the a value didn't change except that it's negative. So instead of opening downwards, upwards, it's going to be opening downwards. So I know it's going to open down. The y-intercept is 6, so I know it crosses here at 6. If it crosses here at 6 and the axis of symmetry is at h, which is -3/2, so x equals -3/2, then I know that there must be a point directly over here, right here, which also must be on the graph because those 2 points are symmetrical and right next to each other there. And so we could, since we know the vertex was right up there, we could graph a rough sketch of our graph with just those 3 points. It might be nice to see if we could factor this one, but I don't think it does factor. If it did, we could try to get the x-intercepts as well. This is going to be a tough one to get all the points exactly correct. The big key here is I want you to be able to find the vertex, h and k, when given standard formula, when given standard form here. So that's really key. Again, we're just using opposite of b over 2a to plug in and find that in vertex form. that is the end of the screen.